So students, let's start with the next section. This section contains 4 questions. Each question has 4 options, out of which one or more than one option may be correct. So let us look at the first question in this section, question number 27. When PCl3 reacts with H3PO3, it forms a product X. Which of the following statements are correct about X? So students, when PCl3 is allowed to react with H3PO3, it forms H4P2O5. Now, if we try and draw the structure of H4P2O5, as examiner seems to be interested in the type of bonds present in that structure, so we'll have a symmetrical structure. So if we try and find out the correct option in this question, option A says that it has 2 POH bonds. This statement is correct, students. It has 2 POH bonds. Option A is correct. Let us look at the B option now. It has 2 pH bonds. That is also correct. There are 2 pH bonds present. And if we look at the C option now, it has 2 PO bonds. This statement is also correct, students. It has 2 PO bonds present in the structure. So statements B and statement C are also correct. Let us look at statement D now. The compound is H4P2O6. So this is incorrect, students. The compound form in this case is H4P2O5 and not H4P2O6. So students, we have to mark the correct statements about this X. So we have to mark option A, B and C as the correct answer to our question. Let us look at the next question, question number 28. Consider the following statements and choose the correct statements. So students, examiner seems to be interested in the zeolites. So let us look at the options now. Option A says zeolites are shape selective catalysts. This statement is correct. The basic structure of aluminosilicates has negative charge, which may be balanced by cations like calcium 2+. Students, this is also correct. Zeolite can cause the cracking of hydrocarbon and isomerization. This statement is also correct, students. It is a fact-based question. Let us look at option D now. For the manufacturing of zeolites, few silicon atoms are replaced by aluminium atoms in 3-dimensional structure of silicon dioxide. So students, the zeolites are also called as aluminosilicates. So obviously some silicon atoms have to be replaced by aluminium atoms in the structure. So students, all 4 of these options are correct. So we have to select all of them as the correct answer to question number 28. Moving on ahead to the next question. Question number 29. Which of the following statements are correct about hydrogen? So let us look at option A now. The HH bond dissociation enthalpy is the highest for a single bond between 2 atoms of diatomic molecules. Students, this statement is correct. The bond which is formed due to SS overlap is very strong and it has a very high bond dissociation enthalpy. Let us look at option B now. NiPd, Ce and Ac can form interstitial hydrides. Students, this statement is correct. NiPd belong to the D block and Ce and Ac belong to the F block. So all 4 of these elements can form interstitial hydrides. Let us look at option C now. Nascent hydrogen obtained from different sources is equally reactive. Students, this statement is incorrect. Nascent hydrogen is a very reactive species and it has a very small lifespan and its reactivity depends upon the source from which it has been created. So statement C is incorrect. Let us look at option D now. In CuSO4.5H2O, only 4 H2O molecules are bonded due to H bonding and 1 bicoordinate bond. Students, this statement is incorrect. There are 4 H2O molecules which are coordinated. So the CuSO4.5H2O, it can be written as CuH2O4 SO4 and dot H2. So the 4 H2O molecules are coordinated, whereas the 5th one is attached by the H bond. Students, this statement is also incorrect again. And in the question, we have to select the correct statements. So students, we have to mark option A and option B as the correct answer to our question. Let us look at the next question now. Question number 30. In which of the following molecule pi back bonding exists? So if we look at BF3, so boron has a vacant p orbital and fluorine has a lone pair of electrons. So it will donate its lone pair into the vacant p orbital of boron. So BF3 has pi back bonding. Let us look at the B option now. So we have trimethylphosphine M, which is coordinate bonded with PCH3 whole thrice. So the sigma bond is formed due to the lone pairs of phosphorus. Now what happens is phosphorus has vacant d orbitals. So it is a good pi acceptor. So what happens is the lone pair of electrons present over the metal get delocalized into the d orbital of the phosphorus atom. So there is a pi back bonding in this case also. Let us look at option C. So we have triethylamine. So SiH3 with nitrogen. So in this case also, students, there is a vacant d orbital which is present over silicon, and there is a lone pair of electrons over nitrogen. So what will happen is this nitrogen will donate its lone pair of electrons to the vacant d orbitals of silicon. So the nitrogen becomes sp2 hybridized, and the geometry which was expected to be tetrahedral is now planar around nitrogen. Okay, so the molecule given in option C also shows back bonding. Let us look at option D now. Bromine dissolved in CCl4. Students, there is no such pi back bonding in bromine and CCl4. So students, for this question we have to select option A, B and C as the correct answer to our question. Let us look at the next question now. So question number 31. Consider the following statement about hydrolysis of some compounds of p block elements and select the correct statements. Let us look at option A now. CCl4, when it is allowed to react with superheated stim, it forms phosgene gas as well as HCl. Students, this statement is correct. Let us look at option B now. The order of hydrolysis of silicon tetrahalides is SiO4 less than SiCl4 less than SiBr4 less than SiI4. So students, there are two competing factors going on in these type of molecules, the silicon tetrahalide. So one is the pi back bonding. So the X has a lone pair of electrons, whereas silicon has a vacant d orbital. So there will be pi back bonding. But the electronegativity of the halogen atom also has to be taken into account. So in this case, students, it is experimental fact that the minus I effect of fluorine, it dominates over the plus M of fluorine. So SiA4 is the most easily hydrolyzable, as due to very strong negative inductive effect, the fluorine atoms create much larger delta positive at the silicon center, which leads to an easy hydrolysis of this structure. So students, this statement is incorrect. Let us look at option C now. SnCl4 can be easily hydrolyzed as compared to SnCl2. Students, this statement is correct. In SnCl4, there is a charge of +4 at the 10 atom, whereas in SnCl2 it is only +2. So greater the charge density of the cation, greater is the ease of hydrolysis. So this statement is also correct. Let us look at option D now. Hydrolysis of PCl3 gives this structure, whereas hydrolysis of AsCl3 gives this structure. So let us look at PCl3 now. So this must have led to the formation of POH whole thrice in the beginning. Plus 3 HCl would have been also formed. However, what happens is the H3PO3 molecule can undergo tautomerization very easily because the lone pairs of phosphorus are active. So we have tautomerization going on, and H3PO3 has this structure finally. However, if we consider the lone pairs over arsenic, the lone pairs over arsenic are much larger and they are not as active as the lone pairs over phosphorus. So these do not undergo tautomerization. So it doesn't tautomerize. Okay, so students, statement D is also correct. So in the question, we have to select the correct statements. So we have to mark option A, C and D as the correct answer to our question.